Hey guys, this is Eddie the Magic Monk. Welcome to another calculus tutorial. Today we want to talk about how to find the area bounded by two curves. So you can see here we have two curves, a curve that's upside down with this equation and another curve that's the right way up with this equation, and we want to find the area in between. So we want to find this shaded area here. And how we can do that is, firstly, we need to know these points of intersection. So we want to find out where these 2 points intersect, where these two curves intersect. And then what we're going to do is we're going to integrate the top equation and find the area below the top curve. So we're going to find this big area, the area below the top curve. And then what we're going to do is we're going to integrate the second equation, which is this equation here, and we're going to find the area between the bottom curve. Alright, we're going to find the area underneath the bottom curve. And then all you have to do to get the shaded area, so all you have to do to get the shaded area, which is here, is you get the area below the top curve, which is the purple area, minus the area underneath the bottom curve, which is the gold area, and then you can get the what color is this? Red area. Okay, so let's write these steps out first before we do anything. So these are all the steps. Number 1, find points of intersection. Number 2, find area below the top curve. Number 3, find the area below the bottom curve. Number 4, area from number 2 minus the area from number 3. Firstly, let's try to find out where the two curves intersect. So step number 1. So let's do step number 1. Finding the intersection. Now, firstly, let's write down the two equations. So we have y equals negative x squared plus 2x plus 8, and y equals x squared minus 2x plus 3. Now, if you remember how to find the intersection between two lines, basically we have to use simultaneous equations. So what that means is we need to find values for x and y that can fit into both equations. Now, to solve a simultaneous equation, what you do is, firstly, let's call this equation 1 and let's call this equation 2. You're going to sub y from equation 1 into equation 2. So here is the expression for y from the first equation. And we're going to substitute this into the y variable in the second equation, and that's because if the y from the first equation is equal to the y from the second equation, then you can just substitute in y from the first one into the second one. So then this becomes negative x squared plus 2x plus 8 equals x squared minus 2x plus 3. So now we have one single equation where x is the only variable, and therefore we can solve it. So let's rearrange the equation. So we have, let's put everything on the right hand side. So we have 0 equals x squared, let's write it all out, plus x squared minus 2x minus 8. So I have moved everything on the left to the right, and then I'm going to combine them. So 0 equals 2x squared minus 4x minus 5. So that is a quadratic equation which we're going to have to solve to find out what the x value is. And this x value will be where the two lines intersect. So let's try this. So let's use the quadratic formula. So a equals 2, b equals -4, c equals -5, and put it all in the quadratic formula. X equals -b plus minus square root of b squared minus 4ac over 2a. And I won't bore you with the details, so I'm just gonna quickly do it. So the answer that I got was 2.7 or -0.87. So let's check on our graph to see whether it's correct. So the first line is 2.87, so yeah, that's approximately 2.9. And the second point was 0.87 negative, so it's about right as well. Okay, so now that we have an almost exact value for the intersection, we're now going to go on to step number 2, which is find the area below the top curve. So curve number 1, where the x squared is negative. So let's do that. So the first step to finding the area is we're going to find the definite integral. So the definite integral from -0.87 to 2.87 of this equation dx. So let's integrate that. So this becomes in squared brackets -x cubed over 3 plus 2x squared over 2. So this can cancel out. Plus 8x in square brackets 2.87 on the top, -0.87 on the bottom. So now let's substitute the numbers in. So we have -2.87 cubed over 3 plus 2.87 squared plus 8 times 2.87 minus negative bracket -0.87 cubed over 3 plus -0.87 squared plus 8 times -0.87. Okay, so now let's put this in the calculator. So I've put them into the calculator separately, and the answer is 29.3. And I've also checked with GeoGebra. So as you can see in GeoGebra, I found the area beneath the top curve, and the answer is 29.3. So this definitely works. And now the next step is we're going to find the area below the bottom curve. So we are pretty much going to repeat the exact same steps. Find the integral from -0.87 to 2.87 of this equation dx. So I won't bore you with the details. I'm just going to work it out and show you guys the answer. So I have integrated it, and now I'm just going to substitute the numbers in, and the top answer minus the bottom answer. So I've substituted the numbers in. Be careful when you substitute in the negative. So in the second part of this, make sure you negative the number first before you cube it. And now we're going to put these in the calculator. So the answer I have found is 11.84, and I'm going to check it with GeoGebra, and you can see that I found the area below the bottom curve, which is area A, which is 11.84. So this has worked properly as well. So now the last thing we're going to do is find the area in between the curves. So part 4, which is the area from the first section minus the area from the second section. So it's 29.3 minus 11.84. So area bound by the two curves equals 29.3 take 11.84, and the answer is 17.46 units squared. Now let's check it with GeoGebra as well, just to see whether it's really 17.46. So I'm gonna delete the two areas that I have found already, and this time I'm gonna use the integral between function in GeoGebra. And what it does is you just type in both of your functions. So we got x squared minus 2x plus 3 and negative x squared plus 2x plus 8, and then we put in our two numbers, so negative 0.87 and 2.87, and it's given us the area is 17.46. And don't worry about the negative sign. As you know, with area we can't have negative numbers, so the answer is just 17.46. Okay, hope you guys learned something today. See you guys next time.